Have you ever felt the Earth's heartbeat? It's a rhythm that pulses beneath our feet. A constant, silent hum that connects every living thing on this planet. We walk upon this world, often oblivious to the profound and complex systems that govern our existence. We see the oceans, the mountains, the vast forests, but these are just the surface of a much deeper, more intricate story. A story written in stone, carried on the wind, whispered through the very fabric of the planet itself. This is our home, a pale blue dot suspended in the vast, silent expanse of space, but it is more alive, more dynamic, and far more mysterious than we can possibly imagine. Today, we embark on a journey. Not to distant galaxies, but deep into the heart of our own world. We will peel back the layers of the familiar to reveal the extraordinary secrets that lie hidden just beyond our perception. From the planet's molten core to the fragile skin of its atmosphere, we will uncover truths that challenge what we think we know about the ground we stand on. These are not tales of fiction, but the incredible, documented realities of our planet. So, settle in, and, prepare to see the Earth as you have never seen it before. Deep within the space between the Earth's surface and the ionosphere, there is a constant, rhythmic pulse. It is not something you can hear with your ears, but it is there, an electromagnetic resonance at an incredibly low frequency. These are the Schumann resonances, often called the Earth's heartbeat. Discovered in the 1950s, this global hum is a standing wave of energy that encircles our world. It is a fundamental property of our planet, a steady beat present for eons. This rhythm is generated by the most powerful electrical events on Earth, lightning strikes. Every second, about 50 bolts flash somewhere on the globe. Each discharge releases a burst of electromagnetic energy that travels around the world, trapped in the cavity formed by the ground and the upper atmosphere. When these waves circle Earth and align with their own tails, they reinforce each other and create a persistent, planetary-scale resonance. Chapter 6. The Earth's magnetic field, our invisible shield, feels like a constant. The needle of a compass reliably points north, a fixed point of reference that has guided explorers for centuries. But this stability is an illusion on a geological timescale. The history of our planet is written in the rocks. They tell a story of a magnetic field that is restless, chaotic, and has flipped upside down hundreds of times. The magnetic north. The South Poles have repeatedly swapped places. This phenomenon is called a geomagnetic reversal. The evidence is imprinted in volcanic rocks. When lava cools and solidifies, magnetic minerals within it align with the Earth's magnetic field at that moment, like tiny frozen compass needles. By studying layers of ancient lava flows from around the world, geologists have built a timeline. The rock record shows poles have reversed, on average, every few 100,000 years. The last full reversal happened about 780,000 years ago. What causes these dramatic flips? The process begins in the Earth's liquid outer core. The churning, molten iron that generates the magnetic field is a turbulent, chaotic system. Sometimes this dynamo becomes unstable. The field weakens and becomes complex. Multiple north and south poles can emerge across the globe. After a period of chaos lasting thousands of years, the field reestablishes itself, often with opposite polarity. The north becomes the south becomes the north. The geological record suggests reversals did not cause mass extinctions. Life has weathered these events many times. The main impact for modern civilization would be technological. A weakened field during transition would let more solar radiation reach the surface, potentially disrupting power grids, satellites, communications. It's not a doomsday event, but a reminder that Earth's forces are in constant flux. Chapter 7. From space, it appears as a delicate turquoise ribbon stitched along the coast of northeastern Australia. It is the only living thing on Earth visible from the moon. This is the Great Barrier Reef, not a single organism, but the largest living structure on the planet. A sprawling, vibrant metropolis built by trillions of tiny animals. A testament to the power of life to shape the very face of the world. A city of coral, stretching for over 2,300 kilometers. The architects are tiny creatures called coral polyps, soft-bodied animals, closely related to jellyfish living in massive colonies. Each polyp builds a hard, protective limestone skeleton around itself. Generation after generation, skeletons build up, one on top of another, creating the intricate, massive structures we call coral reefs, master builders of the marine world, work accumulated over 500,000 years. This underwater world is bursting with life. The reef provides food and shelter for a quarter of all marine species, despite covering less than 1% of the ocean floor. From the smallest shrimp to the largest sharks, countless creatures depend on this intricate labyrinth for survival. A biodiversity hotspot, a library of genetic information, one of the most complex and beautiful ecosystems on Earth, a natural wonder of the world. But this wonder is in peril. Its sensitivity makes it vibrant and incredibly fragile. Rising ocean temperatures are causing widespread coral bleaching, where corals expel the symbiotic algae that give them food and color, leaving ghostly white skeletons. Ocean acidification and pollution add to the pressure. The Great Barrier Reef is a profound symbol of nature's creative power and the immense responsibility we now hold for its future. We experience the Earth's surface as solid and permanent, Mountains seem eternal, continents appear fixed in place, but this is a deception of our short lifespans. The ground beneath us is in constant slow-motion turmoil. The entire surface of our planet is broken into giant, rigid plates that are perpetually moving, grinding against, sliding past, diving beneath one another. This is the theory of plate tectonics. It is the engine that recycles our world's surface and shapes every landscape we know. This process begins deep in the oceans, at mid-ocean ridges. Here, magma from the mantle wells up, creating new crust that pushes the plates apart. This is the birthplace of the seafloor. On the other side of the plate, old, dense oceanic crust dives back down into the mantle at subduction zones, often creating deep ocean trenches. This planetary-scale conveyor belt is constantly creating new crust in one place and destroying it in another. Continents, made of lighter rock, are carried along for the ride like passengers on these massive plates. Over hundreds of millions of years, this slow dance has dramatically rearranged the face of the planet. Continents have drifted apart, collided, merged, forming and breaking up supercontinents like Pangaea. When continents collide, the immense pressure buckles and folds the crust, thrusting up magnificent mountain ranges like the Himalayas. The powerful earthquakes that shake our cities and the volcanoes that build new land are all surface expressions of this deep, relentless movement. Plate tectonics is the Earth's way of renewing itself. It recycles elements essential for life, regulates the planet's long-term climate by cycling carbon, and drives the geological activity that makes our world so dynamic. Without it, the Earth might be a flat, static, and largely lifeless water world. The very ground we take for granted is the product of an epic, ongoing story of destruction and creation, a story written in the language of moving continents and rising mountains. We live at the bottom of an ocean of air we call the atmosphere. It is our shield, our blanket, and the source of the very air we breathe. It feels vast, stretching up to an endless blue sky. But this perception of immensity is a profound illusion. In reality, the layer of air that sustains all known life is astonishingly thin and fragile. If the Earth were the size of an apple, the atmosphere would be no thicker than the skin of that apple. This delicate film, held in place only by the pull of gravity, is all that separates us from the cold, airless vacuum of space. It is composed of distinct layers, each with a critical role. The troposphere, the layer closest to the ground, is where our weather happens. Above that, the stratosphere contains the vital ozone layer. The ozone layer absorbs the most harmful ultraviolet radiation from the sun, protecting life on the surface. Without this thin blanket, Earth would be a barren world. It moderates our climate, trapping heat from the sun to keep the planet warm enough for liquid water. The greenhouse effect. It also acts as a shield against a constant barrage from space. Every day, millions of meteoroids, small fragments of rock and ice, plummet towards Earth. Almost all of them burn up harmlessly in the atmosphere, creating the fleeting streaks of light we call shooting stars. Seeing our planet from space reveals this truth most starkly. Astronauts describe the breathtaking sight of the thin, glowing blue line of the atmosphere curving against the blackness of space. It is a vivid, humbling reminder of the fragility of our world. All of human history, all of life as we know it, has played out within this incredibly thin, precious layer. It is the membrane that encloses our living world, and its protection is not something we can afford to take for granted. The air we breathe today, rich in life-giving oxygen, feels like an eternal and fundamental feature of our planet. But for the first half of Earth's history, the atmosphere was a toxic brew of methane, ammonia, and carbon dioxide, completely devoid of free oxygen. The world was a place for aliens, inhabited only by single-celled microbes.